All right. So can you explain me one more time your requirement? Okay, you want me to add another LAN here? I'll just add on computer. You're going to have HSRP here? Oh, okay. Then I need. Okay, so just we'll connect here, no? For now, you can do the HSRP. Yeah. Then I have to configure this part as well. So let me pass the recording. We will. IP is 166.0.124, 100.66.0.6, the gateway. All right, so I'll go to VIOS 6. So from here on, I'm not going to say VIOS, I'm going to say router 6, router 5, router 9, something like that. Now router 4, you call this as router 4, don't call it as VIOS, it's difficult for us to pronounce. So better make it simple, 654 like that we talk when we discuss. So on router 6, let me use the notepad. G00 will have 6 here, and this is going to have 166. Right. Done. So now what I'm expecting is, I'm expecting ping from this computer to this computer. It's within an office. I'm expecting a ping. If EIGRP is good, I should be able to ping. I'm here on this. No, I'll go to the computer. VPC. I'm here in VPC. I'm going to ping 100.66. No, no, 54.0.9. If EIGRP is good, I should be pinging this. But why I'm not pinging? There is another problem. The problem is the gateway. You see on this computer the gateway is shown as 254, 54 to 54, which doesn't exist, as of now. So let us bring HSRP. I'll go to router 5 and configure HSRP. Interface G00, sorry, IP standby, standby IP, standby the group ID. Okay, I'm going to give the group ID 1, IP, address is 100.54.0.254. So this is going to be the gateway primary. We can enable preemption if you want. Those things we'll not do it now, we'll do it later. Let me go to switch 4, router 4, enable HSRP. Interface G0/0, IP standby group ID 1, IP 100.54.0.254. So now show standby. It shows that the virtual IP is this. The active device is router 5, that's correct. And this is going to be the standby shortly. Okay, it says standby is local, the active is router 5. Now let us go back to that computer VPC and try pinging the other computer in the LAN. Okay, so let me try to check the routing table on this. Show IP route. We do have route to reach 100. Let's try to ping from here. See, from LAN it works. In LAN it works. But when you come from another network, it didn't work. The problem is this PC is responding to router 5. On router 5, I need to reroute it again back like this. That's the problem. Because this PC has got this as the gateway, not this as the gateway. You are not able to ping here. If you change the gateway on VPC 9, then the ping can be expected. Let me try to change the gateway as 6. Now if I go back and try the ping, so there's some other issue then. 154.09, 154.09, that's right. I'm just trying to ping from here. Very simple ping. Let's go to show 166.01. Just trying to ping the directly connected gateway. The problem is here. The problem is on this route. 100, I have put 266. That's the problem. It should be 0 there. Okay. Now we are expecting ping from this VPC. The gateway is pinging. Now I'm going to ping the other computer, which is 9. This is also pinging. Now let me go and change the gateway on VPC 9 back to the 254 address. And now let me try pinging from this VPC. Good, it pings. So we have reachability within this office. Very well. I want to try pinging the standby address 254 HSRP address. Even that is pinging. So HSRP is working fine. And the primary is router 5. Now next is we are going to run EBGP between these two. I'll go to router 5 and configure router BGP 200, neighbor 200.35.35.3, remote AS is 100. And there is no IBGP between router 5 and 4, that's what you said. So let me go to router 4, router BGP 200, neighbor is 200.24.24.2, remote AS is this. Likewise, we'll go to 3, and we are going to have IBGP and EBGP. Router BGP 100, neighbor is 10.13.0.1, 10.13.13.1. Remote AS is 100, which is IBGP. Are we going to have IBGP between these two? No connection, no physical connection. I'm talking about IBGP. Okay. So that you no need to have a route reflector. But if you want to use route reflector, you no need a neighbor. You want route reflector or without route reflector? Okay, let's not have another IBGP. We'll have only RR. Is that correct? Yeah, because that's what you have drawn here. So I'm going with yours. Right, so let us go to router 2. And have IBGP, router BGP 100, neighbor is 10.12.0.12.12.1, remote AS is 100, and nothing more here. We'll go to VIOS 1. Enable host name, router BGP 100, neighbor is 10.13.13.3, remote AS is 100, neighbor is 10.12.12.2, remote AS is 100, and the network that I would like to advertise is 101 mask 255.255.255, and the other network is 11.11.11.0 mask is that 11 is the local LAN, this one. We're advertising these two LAN networks in BGP. Now, I'm expecting these networks to be available on VIOS 5. Let me go to router 5 and check the routing table. Show IP BGP, show IP BGP. Oh, I don't see even BGP. Show IP BGP summary. The neighbor is configured, but unfortunately, I'm not able to see neighbor. The reason is we have not configured eBGP here. Sorry, I forgot. On VIOS 3, neighbor is 200, 35, 35, 5. Remote AS is 200. Likewise, I'll go to router 2. Neighbor is 200, 24, 24, 4. Remote AS is 200. All right, I'm expecting now routes on both 5 and 4. You see, we got two prefixes learned, and they are 1, 1, 1, and 11. This from autonomous system 100. You will also see the same on router 4. Show IP BGP. You're seeing the same. Now, what is the expectation? Whenever we ping from this PC here, VPC or VPC9, the traffic should leave 5 via router 5. Likewise, whenever the return traffic comes out, it should come back via 3. Am I right? Okay. First of all, let us see whether we have reachability from router 6. We will not have. Why? Because we do not have BGP. Now, you don't want to have BGP, or you want to have it here. If you have BGP here, you no need to redistribute into EIGRP. What's your point? What do you want me to do? If you are running BGP, if you want only redistribution. Okay. So you want to redistribute from BGP to EIGRP. In that case, you have to do redistribution on both the routers, 4 and 5. No problem. Let's do the redistribution. Go to router 5 and okay, then there will be another problem. This next stop will not be reachable from router 6. When you redistribute, okay, let's redistribute first. Router EIGRP 200, redistribute BGP 200. Metric weights are, let's say, bandwidth, and then delay, and then reliability, then load and MTU. I'll repeat the same thing on router 4. See, I don't need to give some other metric. If I want to prefer 5 and only if 5 is not available, I want to prefer 4, then I'll do some changes in the metric now. So instead of pasting bandwidth as 1000, I'll say bandwidth as 800. Right, and then the delay as I'll increase the delay here. Delay on the previous one I gave 1, here I'm going to give delay state 10, and then the reliability is that's not considered anyhow. I don't need to care about it. Okay, now let us go to router 6 and see the route in the routing table. Enable show IP route EIGRP. And we see that the traffic prefers to go via router 5 only. Now let's go and shut down router 5's interface. Interface G0/0 shut down. You need to give some time for the convergence. EIGRP is fast in convergence. It's not slow like BGP. But still you need to give some considerable time. See, now only 5 has gone down. Now you can see it is shifting to 4 automatically. Now let's go and bring the interface up and see whether the interface goes back. I said no shutdown, and I'm expecting, if you want this to be active, then you need to set preemption. So standby 1 preempt, standby 1 priority. See, it's going to standby. I don't want it to be standby. I want this to be active. So I am going to give priority 200. So this will become active whenever this is available. Packet should go via 5. Only if 5 is not available, it should go via 4. So now 5 is available. I'm expecting the packet to go via 5. So go back and check the routing table. It goes via 5. Now, testing. But for that, I need to advertise these networks. 100.54 and 100.66 needs to be advertised in BGP, which can be done here. You don't need to redistribute from EIGRP to BGP. You can advertise it from 5 itself, because 5 in the routing table, please listen, it's important. Because 5 already knows 100.66. You don't need to redistribute. You can ask router BGP 200 to advertise what is there in the routing table. Advertise this network, mask. So you don't need to go advertise in R6 only. You can advertise anywhere. If it is there in the routing table, you can advertise even from router 5. And one another network I want to advertise is 100.54.0.0 mask, which is directly connected network to router 5. Now I need to do the same thing on router 4 also. Do show history. It's not here. Okay, in router 4 also I need to advertise. So let me go to router 4. Router BGP 200, network 100.66. Anyway, why are you? Okay, yeah, correct. Let me check first whether I'm learning the route. Do show IP route, EIG. Of course, I am learning that. I can advertise it. Another network is 100.54.0.0 mask. It's exactly same thing what we did in router 5. As a result, if you go to VIOS 1, you will find those networks via BGP. Show IP route BGP. Still not yet come. We need to wait. Show IP BGP. Okay, it has come now. 54 and 66. But the problem is these are all not known next stop address. So we need to say next stop self on 3 and 2. Sheikh, do you remember all these things that you learned? Neighbor 10.13.13.1. Next hop self. Likewise, I'll go to VIOS 2. Router BGP 100. Neighbor is 10.12.12.1. Next hop self. And also, as I said, we need to configure route reflector here. Router BGP 100. Neighbor 10, 13, 13, 3. Route reflector client. We can also make another one. Any one if you do it's enough, but I'm just doing for my satisfaction. Now let's check the routing table, show IP route. Oh, look at this. You are learning 100.66 from autonomous system 200. And you are learning 154 also. And now let's go and see. See, okay, look at this. It is exiting via router 2. That's not our desire. We want it to exit via router 3. So go to router 3, set local preference. Router BGP 200, sorry, 100. BGP local BGP local preference BGP default local preference is 500. Now refresh the clear IP BGP star soft. And now if you go to iOS 1, I should see 3 as the gateway. 3 is the preferred exit. The preferred exit. In case if this fails, it will automatically switch. You can shut down and verify that. Let's do it later. Now let us go to router 6 and see. So this exits on router 5 and it will go to router 3. Even here also it exits on router 3, goes via this. All right. Now what is next? Next is We need to test. From here, let's try pinging 11, 11, 11, 11, which is the remote computer. We are able to ping. We are able to ping from this right to that left. And let's trace the route. Now you can see it goes to 6, and from 6 it goes to 5, and from 5 it goes to 3, and then to 1, and then at last to the final destination. Likewise, let's go to the VPC 11, and trace route to to 100.66.0.1. Trace. And here you see it goes out via 3, enters into 5, blah, blah, blah. Now let us shut down this port and see what happens. Go to 5 and shut down. When you shut down, it should switch to another gateway. Give some time for the converge. Okay, it is converged. It is now exiting via 4. Now when it exits via 4, it will go like this. Okay, listen carefully. It will go like this. And it will ping, but because of the local preferences, it will try to go this way. Will that be possible? No. Why? You have shut down this port. There is no update of this BGP 200 going out here. See, BGP is a bit slow. Sometime it will try to go here, try to go out, but after some time it will not try also because the updates are not going to come this way. The link is down. 154 advertisement and 166 advertisement is no more given to router 3. So there will be only one path available via 2. It will go via 2. Let us check whether it is happening. But BGP is a bit slow. It will happen after some time. Let's try. Cool, it happens. It goes out via 4. And that's it. It is not getting dropped after coming here, which is cool. You don't need to do anything to achieve this. BGP is taking care of it. Let us also go to 11 and try this. Cool, let's see it exits via 2. No confusion. Automatically it is taken care. Did you understand? Let's go and bring that interface on 5 back and see whether it is falling back to the original path. It will. All right. Again, sometime, few packets will be lost because of BGP's convergence time. Otherwise, it will be faster. Now, going back again, I'm tracing the route from VPC on the right, and it goes via 5 and 3. And I'll go to 11 and trace. Again, it goes via, oh no, give some time, BGP, it is slow in convergence. Still, it did not receive any update from 5. Till that time, it will go via the bottom path. BGP is slow. Look at this. It has switched now. You see? It has switched now. You don't need to do anything for this. Just few seconds back, it was going via 2 because of BGP slow convergence. And now it has switched back to the original path that you love to have when router 5 and router 3 is alive. That's all. I hope I answered your query. mm, mm. Mm. Of course. See, only if packet comes to 4, it goes to 2 because EBGP is preferred over IBGP. For that, what you need to do is you need to set high local preference on router 5. Only then it will go out via 5. Yeah. Okay, I understand now your question. See, okay, of course, too, because that's the best one. No one on earth will like to go via 5. No, you see, I'll tell you, no one, after packet coming here, no one will take a right turn because it's a waste of bandwidth and this CPU, this bandwidth, and this bandwidth. Instead, this is the best. This is the best. So no one on earth will try to go like this once the packet comes here. That is why it is designed like this. But if you say, no, 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 I always want to take this path, then we have to do IP SLA, IP service level agreement. You need to trace from here to here. As long as this is available, as long as this is available, hold on, wait, no, no, that's not true. If any packet comes to this, yeah, that's what I'm saying. Let's say they are connected to a network, let's say 80.0.0.1. Now it will come to the gateway 80.0.0.4. Now in the gateway, it will check for 11.11.11.11. In that case, it will exit like this. But if the gateway is HSRP's floating address, no chance it will exit like this. It will only go like this. But if your gateway is something else, like 80.0.0.4, it will exit just like that outside, as you said. It will exit like this. But that is what good. That is why they made it as default. But if you say, no, I don't like the default, if you say, I don't want to exit this way, then we need to write the preferred gateway. We need to write PBR, policy-based routing. We need to say your gateway is 10.54.0.254, which is overriding the routing table. You are trying to ignore what routing table says. You are giving your own gateway. But it's not necessary. I don't think in real world you need that thing, but it is possible. You need to write route map, and then you need to say your gateway preferred next hop is 100.54.0.254. So that traffic, instead of going to router 2, it will go to router 5. But again, there's a problem. If this link goes down, your Policy-based routing should get cancelled. Further, you need to keep tracing the link with ICMP. If the link fails, you need to make that policy-based routing cancelled. These are all, unnecessary work, but it is possible. You can do it. But they are not really the right way of doing. Problem solved. There won't be any problem. If you enable IBGP, problem solved. Local preference will take care. You need to just put the local preference on router 5. Boom. Let me show you that. From router 4, if you check the gateway now, show IP route 11.11.11.11, of course it is going to show you router 2. But if you want router 5 to be shown here, you need IBGP between 4 and 5, router BGP 200, neighbor is 100.54.0.5, remote AS is 200, and then go to router 5, router BGP 200, neighbor is 100.54.0.4, remote AS is 200, sorry. Now I'm expecting an IBGP neighbor. No, even here I made that mistake. That is why. This is funny. Oh. Hopefully I did it now. Okay, now I need to say router BGP 200 and BGP default network default local preference 400. Clear IBGP star soft. Now what is next? I want to show you the route in the routing table of router 4. Earlier when I was checking this, it was showing 2, but this time I'm expecting 4. If next up self is given, that is important because unreachable next up. So on router 5, Sorry, next upset. Okay, so let us check the routing table now. You see? All right, now let us shut down router 5. Interface G00. Now, because this interface is down, the the routing table will now point towards 2 shortly. BGP is a bit slow, you need to be patient. BGP is slow. Still, it's pointing towards 5. BGP needs to get the notification or it has to time out. I think the neighborship is still there. Show IP BGP summary. You see the neighbor still continues. That's the problem. Even though it will wait for 180 seconds. BGP is slow in convergence. You have to accept this. If you want the immediate change, then you have to clear BGP. Means hard reset, soft reset would work. Ping this address. Definitely this is not going to ping because we have shut down. But BGP still holds it. See, the last update is 1 minute 27 seconds. It has to time out 3 minutes 180 seconds. After that, it will switch to 2. 1 minute 47 seconds. Two minutes. You need to wait another 1 minute for the switchover to happen. This we cannot do anything because this is BGP timer. See, now notification has come. Now only the notification has come. So it is 2. So if you want, you can go and change the notification timer to make this fast. I'm going to say no shutdown to this so that I want to check whether it goes back to router 5. Okay, now it has gone back to 5. Right, so going back is easy because notification comes immediately, but when something goes down, notification takes time. You got the question answered?